Hello everyone and welcome to an audio for Liberty County High School Algebra 2 Honors class. Today we're going to be talking about multiplying and dividing radical expressions. Beginning of this video, when you talk about a few theorems and properties that we have in Chapter 6, Section 2, one of those being the product of radicals. If an nth root of a and an nth root of b are real numbers, then the nth root of a multiplied by the nth root of b will equal the nth root of a times b. And what we actually mean by this is that if we have two radicals that have the same index, remember when we talk about an index, we're talking about this little number right here. In this case, we're talking about n's. Well, when we talk about this, we can multiply these expressions under the radical. So a times b, put them under one radical with that same index. For example, if we have the cube root of 2x times the cube root of 3x, so we're going to have cube root of 2x multiplied by 3x. Well, we know that 2 times 3 is 6, and x times x is x squared, all under that same radical. And then from here we would simplify if we can. In this case, we cannot. Alright, so division. If nth root of a and nth root of b are real numbers, then the nth root of a divided by nth root of b can also be written like this. Top, or the numerator, bottom, or the denominator, is equal to the nth root of a divided by b. Okay, and we see that what this means is that we divide the expressions under the radical, put them under the same radical, but yet again, index has to match. So these index must match. Okay. For example, if I have the fifth root of 36x to the fourth divided by the fifth root of 9x, it says that we can put them under the same radical with the index. 36 divided by 9, that's the number 4. X to the fourth divided by x is x cubed, rule of exponents. Remember, we have x to the fourth over x. Technically, this has a little 1. And what we really mean is we're doing x to the 4 minus 1, which is x cubed. Yet again, we can simplify if we can. In this case, we cannot. All right. Roots of powers. If you have an even root that produces a variable with an odd exponent, you must place the variable in absolute values. Alright, when we're talking about this, we're talking about even roots. So an even root is the same thing as saying an even index. So in this case, we're looking right here at an even root or an even index. If that is the case, then we're looking to see if we need to apply absolute values. Well, x to the 12th, y to the 8th, we're taking how many groups of 4 can I get out of 12? I know I can get 3. How many groups of 4 can I get out of 8? I can get 2. Once we've done that step, we're looking which one of these exponents is odd. Well, x cubed has a 3. 3 is an odd number, therefore that variable must be isolated with an absolute value. We do not put them both, only the odd ones. Now, if there's multiple odd ones, we would then put multiple odd variables in the absolute value. If you have an odd root or radical with an odd index, absolute value is not needed. Okay, yet again right here, cube root, that's odd. Once we see this, we automatically know we don't have to worry about absolute values because odd radicals can have negative answers. Even radicals cannot unless we're talking about imaginaries, and for right now, we're not going to discuss imaginaries. So, how many groups of 6 can I get with 3? That's 2. How many groups of 3 can I get out of 9? That's 3. The index is radical is odd, thus absolute value is not needed. Alright, Perfect squares, for this you're going to need perfect squares, perfect cubes. You got perfect square list up to 13, perfect cube list up to 13. I also want us to generate a perfect fourth roots. So 1 to the fourth, we're not going to go all the way to 13, but 1 to the fourth is 1. 2 to the fourth is 16. 3 to the fourth, 81. 4 to the fourth, excuse me. So 4 to the fourth is 4 times 4 times 4 times 4. Or, since we already know the perfect cube is 64, we're going to do 64 multiplied by 4. Let's see, 4 times 4 is 16, carry the 1. 6 times 4 is 24, plus 1 is 25, so 256. 5 to the fourth power, 125 times 5, that's 625. I think that should be enough for this worksheet. I don't think you need anything higher than this. But remember that you can continue to generate these. 6 to the fourth will be 6 times 6 times 6 times 6, or 216 times 6. You can continue to generate them if you need to, but for this case, I don't think we're going to need any more than this. Alright, let's actually get down to some problems. Alright, we need to multiply and simplify. We first check indexes. Are the indexes the same? In this case, we both have square roots, so we're just going to multiply the numbers and see what we get. So 24 times 3, that's the number 72. And from this point we see, can we break this down? This is where that perfect square list comes into play. Well, I know off the bat that 9 goes into 72. But I also know that 72 is 36 times 2. We try to go with the largest perfect square or perfect cube or whatever root you're going with. We try to use the largest, so we have less work to do. So I'm going to go with 36. So 36 times square root of 2, 36 is 6, and we still have square root of 2. And that's our simplified answer. Now we're going to throw in some variables. Check indexes, still square root, still fine. Cube root times fifth root. Exponent rule says if I have xm times x n, then I add m and n together. So I'm just going to add up these two numbers. Really, I have x to the 8th power. Well, how many groups of 2 can I get out of 8? I know I can get 4 of them. Remember to check, since this is even, we check for an odd exponent. In this case, we don't have one, therefore we do not need absolute values. So no absolute value. And even produce an even. Okay, fourth roots. Fourth root of this multiplied by fourth root of that. Indexes match. Therefore, I can multiply. We're yet again just adding exponents. So 15 and 5 is 20. 2 and 7, that's 9. Now we go through our check. How many groups of 4 can I get out of 20? I can get 5 of them. How many groups of 4 can I get out of 9? I can get 2, but I do have 1 left over. Now we check, we had an even index, and we check for odd exponents. Here we have a 5, so we need absolute value right here. I'll write a little note out here. X to the fifth is an absolute value because we had even index and that produced an odd exponent. Okay. Yet again, cube roots. Multiply everything together. I'm going to work up here because this one's a little bit longer. 25 times 10, that's 250. Squared times 7, so that's going to be x to the ninth. Y and y squared, that's y to the cube. Now in this case, since I've got a number involved, I'm going to separate this out. I'm going to say this is the cube root of 250 multiplied by the cube root of x to the ninth y cube. This way I can deal with these independently. I already know how to deal with this. Cube root, how many 3's go into 9? Well, there are 3 of them. And how many 3's are going to go into this one? There's only 1. So I know this part. This is the easy one. No absolute value. Here, I've got to deal with numbers. I need to know a cube root that goes into 250. That's what that list is up there. I can't scroll up because of this Mobi pad. But looking at that list, I do know that this can be the cube root of 125 and the cube root of 2. Because 125 times 2 is 250. Cube root of 125, that's 5. Nothing I can do with the cube root of 2. So now I write this all together as a list. I have a 5, I have an x cubed, I have a y, and I have the cube root of 2. And yet again, we need no absolute value. Because we had an odd index. Alright, last one before we have a U trisection. Fourth root, now we have 3 variables and some numbers to deal with. I'm going to work up here. So I'm going to multiply everything together. Fourth root, 8 times 4, that's 32. I have x to the fifth and x cubed, therefore I have x to the 8th. Y squared and y squared is y to the 4th. X to the 7th and, not xz, sorry about that, z to the 7 and z to the 6, that's z to the 13. Now, just before I'm going to split out numbers and variables, fourth root, 32. And I've got the fourth root of all of my variables, x to the 8, y to the 4, z to the 13. Let's go ahead and deal with variables since we know how to do these very easily. 4 groups. I need to make groups of 4. How many can I make with 8? We know that's 2. Groups of 4 with 4. That one's an easy one. It's just one group. Groups of 4 from 13. Well, 13 doesn't divide by 4, but I can do 12 plus 1. So I can make 3 groups with 1 left over. Because 3 times 4 is 12, plus that 1 extra would make my 13. So I do have all of them accounted for. Over here, fourth roots, this is why we need that fourth root list that we generated. We do know from this list that we have 16 and 2. And the fourth root of 16 is 2. Now let me make that looks like a z. That's a 2, as well as that one. Now let's multiply and put everything together. So on the outside of the radical, I have 2x squared, fix that, square, y, z cubed, and under the fourth root radical, I've got a 2 and a z. And this would be my completed answer. and this goes over here to number 5. Alright, so down here at the bottom we've got a you try section. This is the point in the video that I would pause video, try to work out these 3 problems using the examples that we did above, use your notes, work through the problems, and then check yourself. So I'll give you a few seconds to pause the video. Okay, at that point I'm hoping that you have paused the video and you've come back to check your answers. If you didn't, you're still not sure of how to work them, that's okay. We're going to work these 3 and we'll see where, let's try to find out where your mistakes may be or try to pick out where your lack of understanding is. Alright, we got cube roots. So initially I'm looking at, do we have similar index? They are the exact same, so I can multiply. If it's an odd index, I know off the bat I do not need absolute value. So, going real quick, this is cube root of x6, y 10. Making my groups, here I can make 2. Here I can make 3, but I've got 1 left over. Alright, going with the next one. This one's a square root, therefore it's an even index. So I've got an even index. I'm looking if I need absolute values or not. Go ahead and multiply together. 5 and 3 is 8. 11 and 1 is 12. Alright, go ahead and get me an answer. Remember, this is an index of 2, so I can make 4 groups. And then here, I can make 6 groups. No absolute value needed. Alright, and last one down here, 4th roots. I'm going to go ahead and clear my page. That way I can work this one up here, 4th root, multiplying my numbers together. So 27 and 6, multiply those together, 7 and 6 is 42. 2 and 6, that's going to be 12, plus 4 is 16, so I've got 162. Alright, variables, 3 and 1. That's 4. 5 and 1 is 6. 1 and 1 is 2. Same as before, split them up. 162. And then 4th root of my variables. Doing variables first, making groups of 4. I can only make 1 group with the x's. I can only make 1 group with the y's with 2 left over, and I can't make anything with z's because 2 is less than 4, so I can't pull anything out. So I have 2 y's left over and I've got 2 z's left over. And because I'm an even index, I know that right here x and y, these are both technically exponents of 1, therefore they have got to be within absolute values. Now let's deal with the hard bit. 162. We're talking about 4th roots. We need to try to find a 4th root that will divide into this number. Remember our 4th root list, we had 1, we had 2 times 2 times 2 times 2 was 16, 3 times 3 times 3 times 3 was 81, 4 times 4 times 4 times 4, that was 256. That one we know we can go ahead and stop. That one can't even be used. Looking at these 3, looking at this number, 81 looks like the candidate. 81 times 2 is 162. And we know this is the number 3. So putting all this together, we've got 3, absolute value of xy, 4th root of 2y squared z squared. Okay, that's everything we got for multiplication. Now you'll see down here my little cliff note. Complete Algebra 2, IXL, L7, L8 to 90%. L7 deals with multiplication. L8 is our division, which you can see the next page. we've got divide and simplify, so we're about to do that now. Let's do some division and simplification here. Same thing as before, except instead of multiplying, we're dividing. Instead of adding exponents, we're going to be subtracting exponents. And then simplification comes out exactly the same. So starting off, 36 and 2, indexes match. So really I'm looking at the square root of 18. Since it's square roots, I want to break it down if I can. 18 is square root of 9 and square root of 2. And we know square root of 9 is 3. Over here, remember I told you could look at these in two different ways. You could either have it already set up as a fraction, or you could have the division symbol in between. So looking at this as the division symbol, this is going to be the numerator, this is the denominator. So we're going to do 75 divided by 3. That's 25. And x squared divided by x, so 2 subtract 1 is just x. We try to break this down. We know that the square root, go ahead and split number and variable, we know that the square root of 25 is just the number 5. Therefore, we're going to go ahead and say this is 5 square root x. Now I do know what you're thinking. Technically, Mr. Reed, this could be the number -5 because -5 times -5 is positive 25. For the assignments that you will be given, let's focus on saying that it is positive. But I do agree with you, technically, this could be -5 times -5 gives me a positive 25. Here, similar, -3 times -3 could give me that positive 9, but let's focus on positives. Okay, so here, cube roots match, I can divide. So 13 and 7, that's 6. 13 minus 7, remember this is the numerator, this is the denominator. So 13 subtract 7 is 6. 5 subtract 1 is 4. And then we go through, how many groups of 3 can I get out of 6? I can get 2 of them. And how many groups of 4? I can only get 1 group of 4 with 1 of them left over. I'll clear my page of these so I have a little more room to work out the others. Number 4, cube roots match, do our division, numerator, denominator. 25 divided by 5. So I'm going to go from here, I'm going to go up here. That's 5. 7 and x, that's just 6. 2 and 1, that's just 1. Now we try to break this thing down. Remember, we separate number, separate variables. Nothing I can do with the number. With the variables, how many groups of 3 can I get from the x? Since there's 6 of them, I can get 2. How many groups can I get from y? I can't get anything from y. There's only 1 of them. I can't make a group of 3 if there's only 1 there. Cube root 5, nothing I can do with him either. So we multiply, get all this stuff back together. I've got x squared, and I've got the cube root of 5y. Alright, last one before the you try section. This one looks like a big one. It's got 3 different variables, just like we saw it before. 3 variables and some numbers. And it's already set up in fractional form, so we're just going to divide going straight down. And I'm going to write it up here to have plenty of room for work. 64 divided by 2. I'm seeing the number 32. 25 and 13. Remember, we subtract top from bottom, therefore I'm seeing the number 12. 13 and 1, I'm seeing the number 12 again. And 27 and 10, I'm seeing the number 17. As before, we split it up. I'm going to do number over here, and we're going to do variables over here. Alright, dealing with numbers, variables first. X12, so I got four groups with 12, that's going to be 3. Same thing with Y, we got 12 of them, we need to break them into groups of 4, we can make 3 groups. 4 groups with 17, I can make 4 groups, but somebody's going to have to stay behind. Because 4 times 4 makes 16, and plus 1 more 17. That's where we kept track of all of our people. Noticing right here, Z has got an even number, therefore I'm not worried about him, but I've got an even index and these two variables have odd exponents, therefore they must have absolute values. Here, we've done this number before, we know this is going to be 16 and 2. And 4th root of 16 is the number 2. So let's write out everything we know. We have 2. We'll put z to the 4th in the front. We have absolute value x cubed, y cubed. And under the 4th root radical, I've got the number 2, and I've got a z. And that is my simplified answer. Alright, at this point, the U-try section is for you. So go ahead and work out these 3, pause the video, work them out, come back in just a minute, and we'll check answers. Okay, hopefully you're returning after pausing the video so that we can work out these 3, and that's the last 3 problems on our lesson for today. So, starting off right here, cube root 81x5y6 divided by cube root 3x squared y. Division symbol in the front, that tells me this is numerator, this is denominator. Up here I'm going to work it out. Cube root 81 and 3, so 81 divided by 3, that is 27. X to the 5th and x squared. When we divide, we subtract exponents, that leaves me with an x cubed. X to the 6 and y, or not 6y to the 6 and y, and that's going to give me y to the 5th when I subtract the exponents. Cube root, we'll separate them. Cube root 27, that's kind of nice because that is a cube root, that's the number 3. This one, cube root of my variables, x cubed and y to the 5th, making my groups, 3 groups. Well, I have 3 people, that's just 1. 3, trying to make a group of 3 with 5, that means I have 1, but 2 people got left out. I feel sad for those 2. Alright, now we write them all out. We have 3xy and the cube root of y squared, no absolute value because odd index. Alright. Already set up as a fraction, we have square roots. So 128 divided by 16. So give me the number 8. 13 and 3, that gives me x to the 10th power. And 15 and 3, that gives me y to the 12th power. Splitting them up. Dealing with variables, remember index is 2, means we're looking at even index, could have absolute values. X to the 10th, breaking into groups of 2's, we've got x to the 5th. 12 breaking into groups, we've got 6, so this one has to have absolute values. 8, perfect square list, we know this square root of 4 and square root of 2, square root of 4 is 2. Can't do anything with this one. Writing out my answer, 2 y to the 6th, absolute value, x to the 5th, square root of 2. Now, I know some of you are thinking, answer, how do I write my answer? technically, commutative property of multiplication says that I can multiply any set of numbers in any order and get the same answer. One thing I would suggest is maybe write it in this format here, where we have number, variables that are not absolute value, and then root at the end. That's just personal preference of mine. But do however you need to. But know that any order you write this in technically is going to be correct because it's commutative property. One thing I would say is make sure if you are typing it, make sure that you exit out of the square root before you keep typing, or these might pop up under the square root, and that would be wrong. Alright, and finally, last question for today. We've got the fourth root of this monster and the fourth root of this monster down here. Go ahead and take care of that real quick. 32 and 4, that's going to be 8. 15 and 13, that's going to be 2. 11 and 1, that's going to be 10. And 18 and 10, that is going to be 8. Split. Number over there, variables over here. Alright, do we have a fourth root that goes into 8? Remember, we have 1 and 16. Well, automatically here, we can stop. 1 goes into it, but that doesn't help us because 8 divided by 1 is still the number 8. So there's nothing that can be done with this. Looking over here, x squared, try to break it into 4 groups. We cannot. Y to the 10, break it into 4 groups. I can make 2 groups, but I'm going to still have 2 guys left over. Fourth root here, z to the 8, I can make 2 groups. So people that are left over, remember I had taken 2 groups out, that's 8, so I have 2 guys left. Oh, we forgot about x. Let's put him back in there. We have x squared, we have a y squared, and z, all of his worked out into groups, that's fine. So writing everything out, y squared, z squared, fourth root, 8, x squared, y squared. Alright, ladies and gentlemen, that is it for today. That is multiplying and dividing radicals. Make sure to work on your homework assignment, and I'll see you in the next video.